My name is Johan Dahlberg. I am a bioinformatician at the SNP&SEQ technology platform. We're located in the building just next to here. And we're part of the National Genomics infrastructure at SciLifeLab, and we provide genotyping and sequencing as a service to Swedish researchers. And I've entitled my presentation here today, Greek Myth and Sequencing, for reasons that I hope will sort of become readily apparent during my talk, so bear with me there. And I will talk about how we process the raw data as it comes off the machine, turning it into a more useful data format. A few words about the SNP&SEQ technology platform. So we've been around for quite some time now. So we started in 2001 as a genotyping operation and branched out into sequencing in 2008. We are, I think, at the moment about 25 full-time equivalents, and we're also recruiting heavily. And one of the reasons for doing so is, of course, that we are getting these high-spec Illumina HiSec X10 instruments, or 5 of those, and 5 are placed at our sister facility in Stockholm. And so this is our machine park at the moment. This is what we're handling, and our whole reason for being. And we work under a ISO accreditation standard, so we really sort of emphasize quality in our work a lot as well. So this plays in not only in the lab, but also in our software development process. And finally, sort of the mandatory sequencing is exploding slide. And I like this one because I made it myself. So this is how many gigabases we've sequenced across the years at SNP&SEQ only. So as you can see, 2014 was quite an expansive year, ending up around 60,000 gigabases sequenced. And we don't see this trend stopping at all. So this is sort of, I guess, the reason that we're all here today, to talk about how can we handle this on the computational side. So, coming into the Greek myth part. So, Sisyphus was a guy in the Greek myth who was apparently very, very smart. So smart that he, on multiple occasions, tried to fool the gods. If you read any Greek mythology at all, you will know that this is not a good idea to do, because you will eventually end up in some kind of horrid punishment. That's what happened to Sisyphus. Once they sort of caught him, they made him carry a stone up a mountain, and just as he was supposed to get up on the top of the hill, he would fall down, and he would have to go down and get it and carry it up again. This is the name that one of my predecessors chose for the system that we have to process raw data. So I think this perhaps is a rather bleak view of how it is to run a core facility, but I guess that there is some truth to it. You do the same thing over and over again. And so this is sort of where we are at right now, and I will explain to that, and then I will go into sort of more on how we envision doing things in the future. This is our basic setup at the moment. So we have these sequencing instruments here. And we push these to a number of processing machines. We have 8 of those at the moment. They're set up in pairs. I will go into more detail about that later. This is where we do our sort of what we call the raw data processing, where we basically go from the BCL files that come out of the instruments onto FASTQ files, which is what the format that you might be more used to working with if you've done bioinformatics analysis. We transfer from here onto the processing area on UPMAX that Ola spoke about earlier today. We do some additional processing there, and then we can just drop it into the user's inboxes on the UPMAX system. So this is extremely convenient as compared to taking a hard drive on the tray and going wherever you need to go. We also drop data off to SwiStore, which is our long-term storage solution. And so we have, as I said, we have 8 processing machines at the moment. These are set up in pairs, which are synced for redundancy. So if one machine goes down, we can take up the mirror version and go from there. Currently, we have about 82 terabytes of ERVD synced storage areas. So this is, of course, doubled in reality, and it's also rated in, of course. And this doesn't include the scratch area. So we have a substantial amount of storage to be able to handle this. Currently, we have a sort of a work in process to shape up a lot of this infrastructure, going from from bare metal machines onto a virtualized solution, and also to use Ansible to provision these. Going into how we view the process of analyzing this data into some more detail. Standing over here is apparently not very much. We get data off our instruments, and there we kick off what is called the demultiplexing part. So from the instrument, you will have a lot of data, and you will not know whose data is whose, and you can split it across the machine. So this is the first step. We do this, and then we do sort of what we call an initial quality control, just checking that everything looks okay. If it is okay, we transfer the data to UPMAX. The line in the middle here, sort of the division between our local systems and UPMAX. And then we transform it into a format that can be, that we can then deliver to the users. Once we've delivered this to the user, you notify the project coordinator that now I've done this. And in parallel to this, we archive data to SweStore. After a certain number of days, we do a readback control, checking that this was successful. And then, as needed, we clear this out. This is all fine and dandy, except for that a lot of this is currently done in a manual fashion. This has been quite okay. For like a year ago, we had fewer machines. These produce data every 11th day or so. So this really wasn't sort of that much of a problem. You did this every second week or so, and it was kind of okay. Now it's starting to become more of a problem as we have more sequencing machines, and these produce data every 3 days. But so every sort of lightning bolt in this graph now shows a manual step. So we have to kick off the multiplexing manually. If we have problems in the quality control, we need to go back and check that manually. However, if it's okay, this continues automatically. Delivery to the user is a manual step. This is that you write an email to the project coordinator. Archiving, checking that is also a manual step, and cleaning out data is also a manual step. So this is not only, of course, very work intensive, it's also prone to human error. So there's a lot of trouble with having this kind of approach. This is where this guy comes in. Hercules is perhaps a bit more famous than Sisyphus. He was a generally badass guy. He went around ancient Greece cleaning out stables and killing monsters. And this is the name for our automation project that we're currently working on. And I will go into a bit more detail on this now. And this is sort of more how we envision the future. And we have a working prototype for this now, but it's not in production yet. So as we sat down to figure out we have this problem, we do a lot of stuff manually, this is not going to work in the long run, we need to do something. What are the conditions that apply to this? Well, first we have to run this on our current hardware. We cannot spend any money on new infrastructure, we need to run it on what we got. We need to be able to gradually move into this, so we cannot sort of just throw out the old stuff and go straight to this. We need to be able to have a gradual process. We want to avoid building sort of a super monolithic system that we would be stuck with for the next 10 years that will obviously not be sort of what we need later, but we wanted smaller components that we could switch easily. And we wanted to enable manual intervention in these steps, because as anyone who's worked in a core facility can tell you, troubleshooting will be a major part of what you spend your day job doing. So you want to be able to go in and check things here. And so I would have wished that this was sort of how we got out of that meeting, sort of saying this, but perhaps a few weeks later, this is sort of what we formulated. So we wanted to build a role-based distributed system, and I will go into detail on what we mean by that now. To begin with, sort of we chose a platform called ACA, or a framework, a Scala framework, that is actor-based, and it is based by message passing. And for those of you not familiar with sort of the actor model of programming, it means that you have self-sustained sort of actors in the system that can only communicate their state with each other through message passing. So sort of saying, hi, this is a message to you, I want you to do this, okay, I can do it or I can't. They have no shared state. This has sort of two very interesting properties. One is that it's easy to encapsulate the functionality within each actor. You know that they cannot really talk to each other except for these messages. The other thing that we got from this, which is really what we wanted, was that this is distributed by default. So we can spread this out across our machines and not have to worry. This is only a matter of configuration. It's not really a matter of the programming model. So we came up with something like this. Really Luca's presentation this morning was really very enlightening to me, because this was very similar. It sounded very similar to what we've done. So we have something like a master in the middle. This is what handles the workflow order, in which order should things be run, and what conditions are set on them, and so on. And it in turn communicates work to different roles spread out across our machine park. We implemented a REST API for this to be able to provide command line interfaces, and also to be able to build a web-based front end and integrate with other systems for this in the future. And what are the roles then? Well, every role sort of handles a specific task in this system. So we have the master that I already mentioned that manages the sort of process flow. We have the watcher, which is what watches for new incoming runs from the machines. We have the demultiplexer, and here I have a few grayed out things. And the reason for this is that the demultiplexer actually now runs Sisyphus. So as I said in the beginning, we need to be able to go sort of and adapt on what we already have, and to be able to switch things one at a time. So this does a lot of things right now, and runs this system. We have a notifier that can send you emails. Perhaps in the future we'll be able to tweet under some cool hashtag, and you can see when we produce data, I don't know. And then in the long run, we also want to, of course, automate delivery, archiving, cleaning up everything, but sort of one thing at a time. We need something that we can deploy as soon as possible, and we're really very close to doing that now. And as I said, this is also then distributed by default. These different roles can be set up on the same machine or across multiple machines, and they will find each other and create a cluster and do the things we ask them to do. So the pros of this is, of course, that we can build on what we already got. We can easily scale this by getting more hardware, and we can easily integrate as well with other tools. The cons is perhaps that the programming model can be somewhat complicated at times, especially when it comes to message delivery guarantees over the network. And there's also some tricky stuff with guaranteeing persistence in this type of system that we're working on. So in summary, we are working on building a system that takes this very dull-looking dark guy into something more like this in the future. Something a bit more fun, something a bit more rock and roll, and that we can kick back and relax a bit more. And if you have any sort of questions that you come up with later, please email me here. This is me on GitHub. And with that, I'd like to open up for questions.
Do you have any questions?
Yes, if you go back to the block diagram, which includes the this one.
This, yes.
How do you find a machine here?
Pardon?
How do you find a machine?
How we define it or how we find one?
Yeah. Well, what is it in the infrastructure?
So a machine is like
is it a mainframe or is it a cluster? What is it?
No, it's a separate sort of just either a virtual or a bare metal machine that we provision to run with certain roles, and you set it up. You set up the IP for where it can find the master, and then it sort of hooks up to that.
Okay, because what I understand here that the master is a sort of surface orchestrator that say, okay, this type of analysis belongs to this type of software, so I'll pass it to this role, and then this role have the required software installed on 1 or 2 machines, and it can use those. Is this correct?
Yes, yeah.
But then why not using a cluster and install all of those software on it as module-based, for example, and this will be much easier. I mean, why having each machine have only part of the software and the other machine have part of the software? Do you find this more efficient? Because
Yes.
this is an interesting
so
experience.
we have so one thing is that we have sort of very heterogeneous hardware. So the same things will
Okay.
not be able to run everywhere. So we want to be able to sort of make sure that this scenario can be handled. And also, as I said, we want to be able to run it on what we already have. Not so, for example, setting up some sort of cluster management system on what we already have was sort of not a feasible solution. We want to be able to pretty much go from where we're at today and deploy an automation on top of that as fast as possible. And this is what we came up with.
Yeah, one last question.
I think that's the interesting part, because now we are moving from the fact provisioning to a thin provisioning, like using moving from the cluster where all the things install and then you add up, you add modules in it. But now we are moving towards Docker based or thin microservices. I think your solution is more towards that area where you actually have thin elements like microservices together and then run jobs there, something like
Exactly,
that.
yeah, something like
So
that.
that's good, because this archive Spark also framework is one of those things which are moving into this direction,
Yes.
microservices.
Thanks a lot again.
Thank you.